Alright, in this video we are going to be talking about exponents. Exponents are a way to represent sort of a shorthand for multiplication. And just to kind of begin by introducing the concept, an exponent tells us how many times to multiply a number by itself. The larger number, what we call the base, is what's being multiplied by itself. And then the exponent, or the number in the top right hand corner, tells us how many times to multiply it by itself. Therefore, 4 to the second power, which is sometimes called squaring, 4 squared, means 4 times 4. 7 to the third power, well, 7's our base, that's what's getting multiplied by itself. And we need to multiply it by itself 3 times, so 7 times 7 times 7. Here we have negative 5 to the fourth. Just because the base is a negative number doesn't change anything. We have negative 5 times negative 5 times negative 5 times negative 5. And just an algebraic representation, if we had y squared, regardless of what y is, that means we need to multiply it by itself, y times y. So we've seen that multiplication can simplify the process of adding. If we work 40 hours a week making $10 each hour, instead of having to add 10 over and over and over again 40 times, we can just simply multiply 40 times 10, and that makes the process of adding a lot simpler. Well, exponents make situations where you have to multiply several times much easier. And this is a new operation. This is a new concept. You could say that exponents to multiplication is analogous to multiplication to addition. A couple of examples. When we talk about place value, exponents are really great. Every time we go up a place value, it's another multiple of 10. Another power of 10, we could say. So, to go from the tens place to 100, we multiply by 10, right? To go from 100 to 1,000, we multiply by 10. And this gets really useful when we're dealing with really large numbers. Instead of saying this is in the, 1,000,000,000,000 place, we just simply say it's in the 10 to the 9th. And we know that that means 10 times itself 9 times, or 1 billion. Another example, music, and there's actually a lot of things that sort of double, which is times 2 over and over again, so we're multiplying over and over again. In music, octaves double. So if we go from one A to another A, we've doubled in frequency. And so we can simplify the process of understanding the notes that we're playing by using exponents. Scientists talk about cells multiplying, or understanding, if you've ever heard anything about like radioactive material, its radioactivity divides by 2 every time. And so that's sort of another example of when we're just multiplying over and over again. And lastly, insurance policies, bank accounts, mortgages, lots of financial investments use interest, specifically what's called compounding interest. And the idea is that the amount of money you have grows by a certain multiple over time. You get a certain amount of extra money, or have to pay a certain amount of extra money over time. And if you've ever had a bank account or a mortgage, especially to any parents that are watching this, we might be familiar with this concept of interest, especially with loans. To understand how to read these things, we need to know a little bit about exponents. And this is great to not get taken advantage of by your insurance policy, or to know how much you can actually expect from your mortgages. So anyways, just an idea that this isn't just some other random math thing, that this actually exists and is used in the world around us. So anyways, some labels. The number getting multiplied by itself is called the base, and the instruction for how many times to multiply it by itself is called the exponent. Just like with multiplication, we have the term, which is the number getting added to itself, and then the number, the coefficient, tells us how many times. So anyways, I want to set up a few examples just to make something clear. I asked this 4 squared plus 5 squared equaled 9 squared. And we can kind of quickly do some mental math and say, well, 4 times 4 is 16, and 5 times 5 is 25. So let's see, 16 times 25, that comes out to equal 41. Well, 41 is clearly not 9 times 9. 9 times 9 is 81. So no, we cannot just simply add the bases. And if we expand this out a little bit, 4 squared plus 5 squared really means 4 times 4 and 5 times 5. And if we remember about order of operations, we can't add these terms until we resolve the multiplication, right? We need to solve 4 times 4 and 5 times 5. So we can't just simply add these bases. So no, this does not work. We also can't just multiply the bases because the exponent is telling us how many times to multiply it by itself. 4 times 5 wouldn't have any exponents. But we have these exponents here. That actually equals 4 times 4 times 5 times 5, which is obviously different than 4 times 5. But lastly, the property that I really want to point out, if we have 4 to the 4th power times 4 to the 3rd, then what this really means is 4 times 4 times 4 times 4, right? So let me get my pen. This is this right here, right? 4 times itself 4 times. And then that's being multiplied by 4 times itself 3 times. And we can kind of visually see what's actually happening here is 4 is just being multiplied by itself 7 times. And this is actually a property that says, hey, if we have some number raised to some power, and we multiply it by that same base but raised to some other power, we can just add the total number of times that base is being multiplied by itself. And I give some examples. This first example I put here to sort of illustrate, this doesn't work, right? We're adding, so we can't simplify this. That's in simplest form. However, here we're multiplying. We have m to the 4th times m to the 3rd, so ultimately m is being multiplied by itself 4, 5, 6, 7 times. So that would be m to the 7th. Same thing here, sort of like up here, the bases are not the same. So we can't just say, oh, well, this is a total of 26, because it's two different numbers. We have y 3 times and a 23 times. This can't be simplified. That's just in simplest form. But lastly, it's okay if we have a negative exponent, and we'll talk about what a negative exponent means in a minute, but if we have a negative exponent, this is b times itself 4 times b times itself negative 3 times. Well, what is 4 plus negative 3? It's 1, right? So that just equals b, or b to the 1st power. So let's talk about what a negative exponent means. We know 4 to the 3rd times 4 to the negative 2 just equals 4. So we've got 4 times itself 3 times. And then something happens here. This negative 2, something happens here where we actually cancel out 2 of these 4s, right? Because we're just left with 4. So what could cancel out 2 of those 4s? And in order to do that, we need to talk a little bit about sort of how we cancel something out in multiplication. And we can kind of simplify this by saying, well, we know that we need 4 times something to equal 1. So any number, 5 times what equals 1? Well, let's recap. When we're talking about adding, to cancel something out, it needs to equal 0, right? Because 0 plus something doesn't do anything. 0 plus 3 is still 3. So to cancel out a number when we're adding, we're gonna need the negative of it, right? If I have the number 5 and I want to cancel it out or make it equal 0, I just add to it negative 5. But that's not what we're doing with exponents, right? We're multiplying over and over and over again. So to cancel something out when we're multiplying, it has to come out to equal 1. Because when we're multiplying, 1 times 3 is what makes no impact. 1 times 3 is still just 3, right? So we need to figure out how to turn 5 into 1 to cancel it out. Well, actually, let me jump back here. So 5 times what equals 1? Well, we can figure out what plus itself 5 times equals 1. And the answer to that is 1/5, right? If we have 1/5 times 5, then that comes out to equal 5/5. And if we remember from our lesson on fractions, which is a few videos back, any number over itself, well, that just equals 1. So back to our example here. 4 to the negative 2 must mean 1 over 4 times 1 over 4. Because these, right, 4 times 1 over 4, well, that's 1. So that kind of cancels out, right? That makes no impact. Because when we're multiplying, 1 makes no impact. And then here we've got 4 times 1 over 4, right? So those cancel out. And we're left with 4 equals 4. And we can kind of expand that to say that 4 to the negative 2 equals 1 over 4 times 1 over 4. So what does this equal? 4 to the negative 3. And I want to point something out, and this is going to kind of simplify working with negative exponents. We saw just a second ago, this must mean 1 over 4 times itself 3 times, right? So we have, I'm going to kind of simplify this. I have 1 over 4 times 1 over 4 times 1 over 4, right? And the question is there an easier way to write this? We say, well, I'm multiplying this by itself over and over again, and exponents are supposed to simplify that. Well, what does this equal? When we multiply fractions, we just multiply across, right? So what's 1 times 1 times 1? Well, that's 1. And then 4 times 4 times 4, well, hey, wait a minute. 4 times 4 times 4, that's 4 to the third. So I can sort of simplify my understanding of negative exponents to say 4 to the negative third just means the inverse of 4 to the third, means the opposite of it, 1 over 4 to the third. So here's a couple practice problems. We can see that this would be what? We've got two 1 over 5s, which are going to cancel out 2 of these 5s, and we're left with 5 squared, right? Which we could go ahead and say is 25 if we wanted. And this is just sort of the outline how positive and negative exponents work together when we're multiplying. So anyways, the next video is going to go in a little bit more depth about exponents, and all of this is leading up to scientific notation. I hope this helps. Thank you so much.